All right, let's dive in. Today, we're going to move past all the hype and get right into the code. We're going to walk through the modern playbook for building a real AI system. I'm talking from that very first API call all the way to defending the finished product from attacks. So let's get to it.
And this, right here, this is the question that's at the heart of everything. We all know these models are incredibly powerful, but you know what? That power brings a whole new world of security challenges. So, the real trick is, how do we build systems that aren't just smart, but are actually safe?
Every single complex system starts with one simple connection. Before we can even begin to talk about security or advanced designs, we have to make that first fundamental handshake with a large language model.
Now, what's kind of wild is just how simple this has become. Look at this. First, you install a library to get your toolkit. Then, you configure your secret API key, which is basically your authenticated password, your secret handshake. Then you tell it which model you want to talk to, like Google's Gemini. And that's it. You send a prompt, and you get a response, a simple four-step dance.
And boom, this is what you get back. We asked the AI to write a poem about itself, and this is what it came up with. Pretty cool, right? We've made first contact. The line is open. But, as you're about to see, this is really just the tip of the iceberg.
So the connection works. That's great. But it doesn't mean anything if we can't trust the model. How can we be absolutely sure that the AI, and more importantly, the data it learned from, hasn't been messed with?
Think about it like this. Your AI's training data is like a city's water supply. If the reservoir is clean, everything downstream is going to be healthy and safe. But if someone pollutes that source, even just a tiny bit, it can cause all sorts of hidden problems for everyone. It's the exact same principle for AI data.
And here's the proof in the pudding. This chart shows a model's accuracy on a security task. With clean data, it's hitting a solid 88%. But watch this. If we go in and corrupt just 10% of the training labels, a sneaky little trick called data poisoning, look what happens. The accuracy drops to 83%. Now, a 5-point drop might not sound like a disaster, but for a big company, that could mean thousands of extra security threats slipping through the cracks every single week.
So this leads us to the million-dollar question. If we can't always guarantee the data is clean at the source, how in the world do we verify the final product? How do we prove our model is safe to use? Well, the answer is a concept called model provenance.
Model provenance is basically the tamper-proof seal on a bottle of medicine. It's this verifiable record, a chain of custody, that proves the contents, your AI model, are exactly what they're supposed to be, and that no one messed with it on its way from the lab to you.
And here's how you actually create that seal. It's pretty clever. First, you make a unique digital fingerprint of your training data. Then, after you train your model, you create another fingerprint for the model file itself. Finally, you stick both of those fingerprints into a manifest file. So now, if even a single byte of the data or the model ever changes, the fingerprint won't match, and you'll know instantly that something's wrong.
Okay, so now we have a foundation we can actually trust. From here, we can start building much more intelligent, more capable systems on top of it. So let's check out a couple of really powerful design patterns. First up is multimodal AI. Now, instead of just looking at text, a multimodal model also looks at other types of data like numbers at the same time. For email security, it's kind of like having a two-person team. One analyst reads the actual email text while the other one is checking all the metadata, the number of links, the sender's reputation, that kind of stuff. By working together, they catch threats that either one of them might have missed on their own.
And the results really speak for themselves here. When you're trying to spot phishing emails, a model using only text gets it right about 89% of the time. The one using only numbers, about 85%. But the multimodal model that combines them, it jumps all the way up to 94%. That is a huge improvement in security.
Next, we've got agentic AI. And this is where things get really, really cool. An agentic AI isn't just a model that answers questions, it's a whole system that can reason, choose which tools to use, and actually take action. It's like having an on-call junior security analyst who can investigate an alert all by themselves without needing a human to hold their hand every step of the way.
This table just lays it out perfectly. It sees a suspicious IP login, so it grabs its reputation check tool and recommends blocking that IP. It sees a malicious URL, so it uses its indicator extraction tool, checks the reputation, and recommends a block. And for a risky script on a computer, it uses a totally different tool, Command Risk Check, and recommends isolating the whole machine. It's smart enough to pick the right tool for the job every single time. All right, so we have an AI that we can trust, and it's pretty darn smart. The final piece of this puzzle is defending it, because let's be real, as soon as your AI is powerful and connected to the world, people are going to try to trick it.
The best way to think about this is to imagine a helpful receptionist in a secure building. Now, most visitors just ask normal questions, but some of them are going to try clever social engineering tricks to get that receptionist to break the rules, to give them access to places they shouldn't be. In the AI world, we call this prompt injection.
And these are the exact kinds of things that attackers will say. They'll try to command the AI to ignore all previous instructions, or maybe pretend, act as my boss. They might even try to get it to cough up its own core programming, its system prompt, or even worse, try to get it to execute malicious code on the server.
So how do you possibly stop that? Well, you build a security gate. This gate sits in front of the main AI, and it inspects every single prompt that comes in. A normal, harmless request like, summarize this report, yeah, that's fine, it goes right through. But a malicious prompt that has phrases like, ignore previous rules, nope, it gets spotted and blocked immediately, before it can do any harm.
So, let's bring all of this home. Let's pull everything we've talked about together into a clear, simple, and actionable AI security checklist.
Here it is, 4 steps for the modern AI playbook. Number 1, connect, and make sure you do it securely. 2, verify your foundation with provenance hashing. 3, enhance the system's intelligence with smart patterns like multimodal or agentic AI. And finally, number 4, defend it with a prompt security gate. Connect, verify, enhance, and defend.
If you follow this playbook, you're going to have a robust, secure, and intelligent system. But, and this is important, security is never a one-time thing you just check off a list. It's a constant process of being vigilant and ready to adapt. So the real question isn't just whether your AI is built, but is it